today's chemistry session. In this session, we will discuss about bonding in coordination compounds. And in a special way, we will discuss about valence bond theory. Because many approaches have been put forth to explain the bonding in coordination compounds. Like crystal field theory CFT, ligand field theory LFT, and then valence bond theory VBT, and so on. Even molecular orbital theory MOT you are familiar with. And then here we are going to discuss about valence bond theory. It is one of the most important approaches to describe the bonding in coordination compounds. Once you know the concepts of valence bond theory, you will be able to predict the geometry of a particular coordination compound. If you are introduced with a coordination compound, you can predict its geometry, its hybridization, and then you can predict whether it is paramagnetic or diamagnetic. You can also say whether it is a low spin complex or a high spin complex. All these things you can predict by using valence bond theory. So it is going to be very important, you know. So before going to have some examples or explanations, you have to be familiar with certain things if you want to deal with the coordination compounds in view of valence bond theory. First thing is, ligands are different. Some are strong field ligands, some are weak field ligands. So you should have some idea by seeing a particular ligand whether it is a strong field ligand or it is a weak field ligand. Only then you can go further. So for example, I have given some examples here for strong field ligands. CO, carbonyl, Cn minus, En, NH3, NO2 minus. All these ligands are strong field ligands that you have to keep in mind. And then weak field ligands, I minus, Br minus, SCN minus, Cl minus, F minus, OH minus. These ligands are weak field ligands. These things you should know. Only then you can predict what to do or how will be the pairing or unpairing, how will be the hybridization works in valence bond theory. So you should know about it crystal clear. Then another thing which usually comes in the exams, like whether this given coordination compound is a low spin complex or high spin complex. In order to answer that, you should know what is a low spin complex and what is a high spin complex. During the formation of a coordination bond in coordination compounds, what happens is ligands approaches the metal ions, donating a pair of electrons by each ligands. They form coordinate covalent bonds. It is done, and then after that it forms hybrid orbitals. New equivalent number of hybrid orbitals are formed. During that, when these ligands are approaching the metal ions, these ligands can be occupied in the N-1d, Ns or Np or Nd orbitals of the metal ion. If it is placed in N-1d, Ns, Np orbitals, like if it is 4s and 4p and 3d, 4s, 4p, then it is N-1 because it is 4s and 4p. So this is N-1, 4 minus 1, 3. If it is placed in 3d, 4s, 4p orbitals, we call it as low spin complex or inner orbital or paired complex. Instead, if the electrons that is donated by the ligands are placed in Ns, Np, Nd orbitals, for example, 4s, 4p, 4d orbitals. In that case, we call it as high spin complex or outer orbital complex or spin free complex. Okay? I hope you have understood. When we do examples more, it will be more clear for you. I have told you how to differentiate a ligand according to its field, whether it is a strong field ligand or it is a weak field ligand. Once you know that, you can easily predict its hybridization, that I will teach you. And once you know the hybridization and the coordination number have to find out, we have already discussed. And once you know the coordination number and its hybridization, you can easily predict the correct geometry of that particular coordination compound. You can see here, if coordination number is 4, there are two possible geometries. One is tetrahedral and the other one is square planar. Then how can you know that which is tetrahedral and which is square planar? So you have to look into the hybridization of that particular central metal atom with the ligands. And what is the hybridization? If it is sp3, the possible geometry or the predicted geometry will be tetrahedral. If it is DSP2, the predicted geometry is square planar. And if you get a coordination compound with coordination number 5, the expected hybridization is sp3d. So you will get the geometry trigonal bipyramidal. So you can easily predict the geometry by looking into its hybridization, that is trigonal bipyramidal. If a coordination compound with coordination number 6, you can have two possible hybridizations, sp3d2 and d2sp3. And what will be the predicted geometry? Octahedral. You know this already, and you can make it very clear by using hybridization. Okay.